Hello guys, welcome to the channel Math Genius. In this channel, I'm going to be uploading videos about maths, any topic. You can write in the comments and I'll make a video on it. But today, we're going to be starting with types of numbers. This is from IGCSE course, subject code 0580 Mathematics. And this is types of numbers. So on the screen, we have 8 types of numbers. So let's start. The first type, the most common type of numbers is integers, which is basically any number that is positive, zero, or negative. So I have some examples such as 0, 1, 2. It's basically any whole number. It can also be negative like -4, -5. Basically any whole number. Then we have natural numbers, which is pretty much the same thing, except it doesn't include 0 and it doesn't include negative numbers. So we have 1, 2, 3, 4, 5, 6, no 0. That's a mistake. And then the next type is prime numbers. Now this is a little tricky, but it's easy. I'll tell you how to find if any number is a prime number. Basically, all prime numbers have two factors, 1 and the number itself. I wrote x because x is the number. So over here, we have few prime numbers such as 2, 3, 5, 7, 11, 13, and so on. All of these numbers have only two factors, 1 and the number itself, such as 2, its factors are 1 and 2, 7, its factors are 1 and 7, 19, 1 and 19. And note that I haven't written 1 here because 1 has only one factor, so it is not a prime number. And it's a little bit confusing, but it's also not a composite number. And composite numbers are basically numbers that have more than two factors and are not prime numbers. So 1 is not a prime number and not a composite number. So keep that in mind. Next, we have square numbers. Square numbers are basically numbers that are that are the product of a number multiplied by itself. So 1 is the product of 1 and 1, and 4 is the product of 2 and 2, 9 is the product of 3 and 3, 16, 4 and 4, 81 is the product of 9 and 9, and so on. So if you want a square number, you can just take any number multiplied by itself and you get a square number. And next is cube numbers. These are similar to square numbers, except it's a number multiplied by itself 3 times. So like 1 times 1 times 1, that gives 1. And then for 8, we have 2 and 2 and 2, 27, 3 and 3 and 3, and so on. Then next we have rational numbers. Any number that is non-recurring and can be represented by a fraction. So all integers, they're rational numbers. Prime numbers are rational numbers. Even decimal numbers are rational numbers, such as 0.56, that's a rational number. 2.34, that's a rational number. But how do you know which number is not a rational number? Basically, any number that isn't a rational number is an irrational number. And an irrational number is any number that cannot be represented as a fraction. Such as, why does this keep happening? Such as 2 over 3. Now, if we had to write this in decimal form, it would be 0.6666 and so on. So this right here is an irrational number. No. This right here is a rational number because it can be in a fraction. But an irrational number is something that cannot be written in a fraction. Such as the root of 2. Now the root of 2 would be something like 1 point blah 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 blah. It will keep going on forever, But the thing is, it's not like one, it's, each number is unique. It's not recurring. So root of 2 is an irrational number, root of 4 is an irrational number, and yeah. But if it was something like 5 over 8 or 8 over 3, that's a rational number because it can be represented by a fraction. Even 2 is a rational number because it's being represented as 2 over 1, and 2 over 1 is a fraction, so it's a rational number. So on, we have reciprocals. Reciprocals are basically like you just flip the fraction. For example, over here we have half. The reciprocal of half is 2, because half, if we switch the numbers, it's 2 over 1, which equals to 2. 1 over 3, the reciprocal will be 3 over 1, which equals to 3. And yeah, and then we also have 3 over 4, which has the reciprocal 4 over 3. And like that, we can take any number such as 8 over 5. And if you want to find the reciprocal of that, we basically flip the numerator and denominator. So the reciprocal will be 5 over 8. So that's all types, all the 8 types of numbers here explained. Now I do have some questions on these to practice. So let me just go there. These are the questions. If you want, you can pause the video, take some time and try and answer these yourself before, I answer them for you. So first, we have a list of numbers, and from here we have to find a multiple of 8. Now to find a multiple of 8, you can write them down: 8, 16, 24, 32, 40, and so on. And from here we can already see that 32 is in the list, so obviously 32 is a multiple of 8. And just in case, you can take all these numbers and divide them by 8, and if you get a whole number, that means it's a multiple of 8. If you get a decimal, it's not. And we're just gonna write 32 here as our answer. Then a square number is a number multiplied by itself. Now over here, 32, the factors of 32 are 4 and 8, 2 and 16, but none of them is a number multiplied by itself. So 32 is not a square number. After that, we have 33. 33 is 11 and 3, and then 1 and 33. None of them is a number by itself, so it's not a square number. Then we have 34. 34 is 1 and 34, and 2 and 17. Not a square number. Then we have 35. 35 is 1 and 35, and 5 and 7. Not a square number. We have 36. 36 can be written as 6 by 6. That means 36 is a square number. It's the square of 6. So our square number is 36. Next, we have to find a prime number. Now, a prime number is any number that has a factor 1 and itself. Now, we already said that 33 has 3 and 11. 1, 3, 11, 34 are its factors, so it's not a prime number. 34, 1, 2, 17, and 34. There's 4 factors, so it's also not a prime number. 35 is a multiple of 5, so it's not a prime number. 36 is a square number, so obviously it's not a prime number. 37 only has the factors of 1 and 37. So 37 is our prime number. And like that, we got a multiple of 8, a square number, and a prime number. All from this list right here. So let's move on to the next question. Again, you can pause the video and solve this out yourself. It's just for practice, so and to explain you how these actually come in IGCSE papers. So from this list, we need to write down a cube number, the smallest number, and a natural number. A cube number is a number multiplied by itself 3 times. So root 5, it's a root, so it's not a cube number. It's a prime number, but it's not a cube number. No, it's not a prime number because that has a root. So it's an irrational number. Negative 7. Negative 7 is not a cube number. 343. 343 is 7 times 7 times 7, and it's a number multiplied by itself 3 times. So that means 343 is a cube number. So we write that there. Now we have to find the smallest number. Now the smallest number, 343 is obviously not the smallest number, so just cut that out. Root 5 is greater than negative 7 because the root of 5 is obviously positive. So we can cut that out. And because we have these negative numbers, we can cut out all the positive numbers. So 0.4 goes away, 2.5 goes away, and 1/3 goes away. Now obviously root 5, it could also have a negative answer, but it's going to be like negative 2 point something, I think. So that's also greater than negative 7, negative 11. So it's not the smallest number. And then from negative 7, negative 11, the smaller number is negative 11. So we write that here, negative 11. And now we need to find a natural number. A natural number is any positive integer and it's not 0. So a positive integer here is 343. So the only natural number here is 343. That's it. Now the next question. Another list of numbers. This time we need a multiple of 7, a cube number, and a prime number. Multiple of 7, 27, not a multiple of 7. 28 is the fourth multiple of 7. 7 times 4. So 28 goes here. A cube number, 27. 27 is 3 times 3 times 3. That's a cube number. It's 3 times 3 times 3. 3 multiplied by itself 3 times. So 27 is a cube number. A prime number, any number that has two factors, 1 and itself. Now 27, it has 3 as a factor. And it has 9 as a factor, so it's not a prime number. 28, 2 and 14, so it's not a prime number. 29 can only be multiplied by 1 in itself. So 29 is our prime number. We can now go to the next question. Write 56 as a product of its prime factors. Now to write any number as a product of its prime factors, there are two methods, and I'm going to explain both of them. The first one is the tree diagram method, in which you just write the number 56, and then you're going to divide it by the smallest prime factor. So 56, first we're going to check if it's divisible by 2, which it is. So we're going to divide it by 2. And then 56 divided by 2, that's 28. And then again, this can be divided by 2. So we're going to divide by 2, 14. Again, 14 can be divided by 2. So it's going to be 2 and 7. And then 7, that's a prime number. So we've already gotten 56 as a product of its prime factors. And those prime factors are 7, 2, 2, and 2. And it's preferable to just circle the prime factors so that you don't get confused. So 56 as a product of prime factors would be 2 times 2 times 2 times 7. 7. And this can be written in short form using indices as 2 to the power of 3 times 7, because there are 3 2's. So 56 as a product of its prime factors would be 2 to the power of 3 times 7. The second method for writing 56 as a product of its prime factors is called the ladder method, in which you just draw like this. You write the number And then let's say you're going to divide it by 2 because it's the smallest prime factor it's divisible with. So you divide it by 2. 56 divided by 2 is 28. Then again you can divide by 2, 14. Again you can divide by 2, 7. And 7 is divided by 7 to give 1. And when you get 1, that's when you stop. And again we have got the factors 2, 2, 2, and 7. So again 56 can be written as 2 to the power of 3 times 7. So I'm just going to take that out. We got the same answer. So that just shows that both methods work. And next question, 23b. Find the lowest common multiple or LCM of 56 and 42. Now to find the LCM of a number, the simplest way to do it is to write both of the numbers as a product of their prime factors. And as in part A, we already got 56 as a product of its prime factors. So we'll just write it down. And now we need to write 42 as a product of its prime factors. Now obviously you can use the 3 method, but I'm just going to write it here. It's 2 times 3 times 7. You can work that out in your book. It's 42. And to find the lowest common multiple, well, actually, let me write this in full form just to make it easier. 2 times 2 times 2 times 7. And to find the lowest common multiple, you have to find the similar factors. And these both are going to find the same factors. So like the same factors over here are 2 and 7. So you're going to write LCM equals 2. Then you take these similar factors, 2 and 7, cut them out. And then you're going to write the remaining factors, which is 2, 2, and 3. So 2, 2, and 3. 2 times 7 is 21. 2 and 2 is 4. 4 and 3, which is 21 times 12, which is 252. So the LCM of 56 and 42 is 252. We can write it here. And next question. Find the highest common factor, HCF, of 90 and 48. Now this is a similar question and we use the same method, except we're only going to use the similar factors to find the HCF, because HCF is the highest common factor. So we need to find the factor. We don't need a multiple, we need a factor. So again, we're going to write both of them as a product of their prime factors. You can use the 3 method, but I'm just going to write it down like this. 90 is 2 times 3 times 3 times 5. And 48 is 2 times 2 times 2 times 2 times 3. And we're going to circle out the similar factors, which is 2 and a 3. And in the HCF, we're going to write only the similar factors, which is 2 and 3, which is 6. So the HCF of 90 and 48 is 6. And now we can move on to the next question. Here is a list of numbers. From this list, write down a prime number and an irrational number. So we have another list of numbers and we need to find 2 types of numbers from these. A prime number is any number which has 2 multiples, one in itself. And 21, it can be multiplied by 3. 3 by 7 is 21, so that's not a prime number. 2 over 3. Now prime numbers are whole numbers, so any fractions or any roots, they're not going to be prime numbers. Then the only option left is 31. 31 indeed only has 2 factors, 1 and 31. So our prime number is 31. Next, we need to find an irrational number. Now, a tip to find an irrational number is to look at all the roots, because most of the time the roots are the irrational numbers, or anything that's not a whole number or a fraction. fraction because fractions are rational numbers. So over here we have root 13 and we have root 121. And we have two options and we don't know which one is the irrational number. Now 121 itself is a square number. So if you find the root of 121 in a calculator or if you know that 121 is in square, you can automatically tell that root 121 is 11. And 11 is a whole number, so it's not a rational number. So the only number left is root 13, which is indeed our rational number. Next, we have to write down a square number greater than 10 and an irrational number. So for a square number greater than 10, we can write down our squares. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 36, and so on. And we need a square number greater than 10. So we have three options here, and obviously more, if you keep multiplying. So any of these, if you write them, you'll get the right answer. I'll just write 16, for simplicity. And that's it. Next, we have an irrational number. Irrational number, as I said, you can write any root 2, root 3, root 5. But you can't write root 4 because the root 4 equals to 2. So make sure it's like a number any number that's not a square number. Or you could just copy root 2 or root 3, So I'll just write root 2 here. Next, we have the common factors of two numbers, 1, 2, 3, 5, and 7. We need to write down the digit that the two numbers must end in. Now, this is a slightly tricky question, but a simple way to do it is to just multiply all the factors. So 1 times, what happened? We were here. Yeah. So 1 times 2 times 3 times 5 times 7. And 1 times 2 times 3 is 6. 5 times 7 is 35. 6 times 35 is 210. And as we can see, the number 210, it ends with a 0, which means it's a multiple of 10. So any number multiplied by this is obviously going to end with 0. So the digit that the two numbers end with is always going to be a 0. So our answer is simply a 0. Next, write 84 as a product of its prime factors. 84 as a product of its prime factors. We're gonna do the tree method here. 84, 2, 42, 2, and 21, 3, and 7. Circle all the prime factors, and we get 84 equals 2 times 2 times 3 times 7, which can also be written as 2 squared times 3 times 7. And that's it. We've completed all the questions. See you next time on Math Genius. I hope you enjoyed this video and definitely learned something. If you need any more help, you can rewatch the video. And if you need help in any other topic, you can write it down in the comments. I hope you enjoyed this video. Thank you for watching and see you next time.